All right, welcome back. Let's just keep going with these. So solve and verify. Um, let's just rewrite this over here. All right, so I wrote this again. What we're going to do here is right off the bat, everything's stuck under the square root symbols right now. I can't really do anything until those go. I got nothing I even could do, so they got to go first. And how we're going to get rid of those is going to be by squaring both sides. We can do that as long as we do it to both sides, right? So I square both sides, they cancel both of those square root symbols, and this all of a sudden gets a lot easier. So what I'm left with is 3x minus 5 is equal to x plus 19. Now all I gotta do is get x's on the same side of the equation and just the other numbers on the other side of the equation. So I'm gonna bring x's to the left side. Doesn't matter, I could go to the right side too, but I'm just gonna bring it to the left side, numbers to the right. So what I'm gonna do is bring x to the left, so I'm gonna subtract x from both sides. So minus x, and what I've got, I'll just write it again here, I've got 3x minus x minus 5 is equal to 19. This minus x and this 3x, I can just collect like terms there, right? So this just ends up being 2x minus 5. And I'll write the whole thing. Minus 5 is equal to 19. Now I just got to get the 5 out of there. It's the next thing I want to get to go. So I'm going to go add 5 to both sides. Plus 5, and I end up with 2x is equal to 19 plus 5 is 24. So x is equal to 12. And just for the sake of time, I'll let you guys put 12 back into the equation. But what you would do to check to see if this is right is that you'd say the original equation. It has to be the original too. It can't be like part way down the equation. So go back to the original equation and you'd say 3 times 12, which is my answer, minus 5, take the square root of it, is equal to square root of 12 plus 19, and they do actually end up checking out, so we're good. You end up getting the left side is equal to the right side. I'll let you guys go through and check that out though. All right, moving on to the next one. So B, I'm just gonna write this down here. All right, so for this one, what we wanted to do on the above ones, right, was to isolate the square root. But we can't really do any better than we have right now, right? This one's gonna kind of be there no matter what we do. So what we gotta do is really just take the square root of both sides right now. But what I can't do, and what you might be tempted to do, is go, okay, well, I'll just go, I'll square that, and I'll square that, and then they'll just go away. But you can't do that. We have to square the entire side. So what I mean by that is we have to do this. Take the square root of this side and square root of this side. And this will look a little bit different. The left side's easy because that's going to be the squared and the square root are going to cancel. And I'm going to have x plus 7, so that's simple enough. But this side now, I can't just get rid of the square root symbol because this squared actually looks like this. And we have to FOIL this. You can kind of see where this came from, eh? So now we got to do that. So I'm just going to start going through the steps here. I'm just going to write x plus 7, and now we have to go just FOIL. So we that one times that one times, oh, missed the one. 1 times that, 1 times 1 at the end. So in the end, this is going to be square root of x plus 2 times square root of x plus 2. It's just going to be x plus 2. And I'm just going to put that in brackets just so I can kind of just keep track of the things I've done. Now what I'm going to have is square root of x plus 2 times 1. So that's just going to be plus square root of x plus 2. And then again, I've got 1 times square root of x plus 2. So x plus 2. And then in the end, I've got 1 times 1 is 1. So there. That's kind of where we're at now. And I'm just going to rewrite this now so it's a little bit like better to look at. This one I've got here can really just be added to that one, right? The like terms. So I'm just even gonna just erase this and go, and I'll erase those brackets now too, just to make things simpler. So x plus 3, I just collected like terms, is all I did, right? Now what I'm gonna do is I'm gonna bring this x over to the left side of the equation. So if I subtract x and subtract x, what I get happen is kind of like in the last question, something happened which makes it easier, is those x's cancel and those x's cancel. So things have gotten easier. The next thing I'm going to do is take this 3, I'm going to move it to the left side. So I'm going to say minus 3, so those cancel, and then minus 3. And now what I'm left with is on the left side I've got 4 is equal to 2 times square root of x plus 2. And it's this, if you're wondering where this 2 came from, it's just because I collected these like terms, right? This and this. One of those and another one of those is 2 of those. So don't be confused by that. That last thing I'm going to do, or not last thing, but I'm moving on. This 2 has to be the next one to go. So I'm going to divide both sides by 2. So divide by 2, divide by 2. Those equal 1 or cancel. So I'm left with 2 is equal to the square root of x plus 2. There, I'm kind of at the point now where last thing I have to do is get the square root symbol. So I just have to square both sides. So that's squared, that's squared. Squared cancels with the square root. I've got 4 is equal to x plus 2. Last thing I gotta do, subtract 2 from both sides. Those cancel, and I've got x is equal to 2. All right, last one we're gonna do. So what we're going to do again is we need to get rid of these square root symbols. So we could technically just go this squared and then this squared, and we could carry on that way, but for the sake of simplicity I'm going to do something a little bit different. I'm going to write it like that goes away and that. What I'm going to do is bring this term, oh, that should be equals, over to the right side of the equation. So I'm going to write it like this. I'm going to say square root of 2x plus 27 is equal to 3 plus square root of 2x. And the reason why I did that is it's just going to be a little bit easier this way. It actually would work both ways. But I find when we take the square of this and we have to expand it, it's going to be a little bit easier to work with that 3 than it will be to work with this big mess over here. So that's the only reason why I did that. But it would work the same way. It would just be more steps doing it the other one. So we're going to take the square of both sides. And I got the square of a square root on this side, so those cancel. And this side, what I've got left is 2x plus 27 is equal to... Now, don't fall into the trap of saying that this is going to be 9 times... or 9 plus 2x, because you're just squaring that one and that one. You have to rewrite this as 3 plus square root of 2x, and then times again 3 plus square root of 2x. That's probably the #1 source of mistakes in these questions is forgetting to do this, so make sure you do. Okay, now what we gotta do is FOIL again. So I'm gonna say, I'm just going to rewrite this on this side again. So 2x plus 27 is equal to 3 times 3 is 9. 3 times square root of 2x is equal to 3 square root of 2x plus, again, another one, 3 square root of 2x. And then lastly, I've got plus just 2x, because the square root times the square root annihilated them, so we just ended up with 2x underneath. Okay, so I'm just going to simplify things a bit here. I've got some like terms, so that 3 and that 3, this could just end up being 6 times the square root of 2x, so I'm just going to write that. And yeah, let's do that for now. 2x plus 27 is equal to 9 plus 6 square root 2x plus 2x. One thing that's kind of jumping out at me right now is that I've got 2x on the right side of the equation and I've got 2x on the left side of the equation. So what's going to happen is if I subtract, like the other questions, we've done this in every one now, if I subtract 2x from this side and subtract 2x from this side, I've gotten rid of that whole term. So things just got a little bit simpler. So I've got 27 is equal to 9 plus 6 times 2x. Now, you might say, well, I got to get rid of the 6 now. That'd be wrong. You got to get rid of the 9 because remember, it's just kind of the thing that's hanging off. I want to get x on its own, and this is kind of the farthest away, so it's the first to go. So right now it's positive 9, so I'm going to subtract 9 from both sides. So 27 minus 9. And I end up with 18 is equal to 6 times square root of 2x. Divide by 6, divide by 6. I've got 3 is equal to square root of 2x. Next step, I got to get rid of the square root symbol, so I'm going to square. I'm going to say 9 is equal to 2x. So x is going to be equal to 9 over 2. And if you plug 9 over 2 back into your original equation, back into this one, you should end up with 3. You should end up with 3 on both sides of the equation. If I had 9 over 2 in there, 9 over 2 in there, we should end up with 3 because 3 is on the right side of the equation. So go ahead and try that if you want. And that's all I'm going to do for this video. So I'll see you guys in class.